All right, here we are, my party people. Welcome in to Fraction Word Problems Part 1. This is going to be a one of two part series where today we're really going to be focusing on, getting our feet wet again, getting that refresher when it comes to fractions, because we all know that word problems are hard enough as it is. And then when we think about fractions inside of word problems, I think we can all agree that that's going to be a recipe for anxiety. So here's today's plan. Number one, we're going to be refreshing on calculating with fractions straight up. Adding, subtracting, multiplying, dividing, that's all we're going to focus on first. Then once we get that refresher in, my party people, we're going to transition into knowing how to take those keywords, taking that English, turning it into math. So again, number one, calculating. Number two, translating the English into math. And then once we have both of these steps nice and wrapped neatly with a bow and tie, then we'll move over to part 3, where we're looking at word problems and applying our basic word problem strategy with every single problem. So again, one little step at a time, we'll get there. So here's how this is going to work, everybody. Let's go ahead and get over to the first page of notes. But here's what I want us to do. I'm going to give you every opportunity to write things down. But first, I want you to put your pencils down and just go ahead, take a moment and listen to me talk about this and write the example out. Once I'm done, then again, I'll give you that time to write down all the notes you need to, and then we'll move on to the next slide. So again, put those pencils down and let's go ahead and check this out. So number one, when it comes to adding or subtracting fractions, everybody, again, specifically with adding or subtracting fractions, the very one thing, the only thing that we have to make sure is true before we actually add or subtract is we have to make sure that the denominators are the same. The way I like to think about it, everybody, is this. I like to think about fractions as pizza. And this is where I will apologize ahead of time, because if there's anybody out there who is hungry, I'm going to ruin your day. But here we go. Let's go ahead and say we're talking about pizza. Let's say I have this box of pizza or this pie, and then let's say we have this pie. So again, the boxes, the pies are the same size themselves, but let's go ahead and go through a little example here. Everybody, let's go ahead and, my name's Coach Anderson, just for the recording's purpose, and I'm going to look in the chat box here, and I'm going to pick out a name. I'm going to pick out Ariane. So let's say, again, my name is Anderson. And then we have Ariane. And let's say Ariane and myself, we ran into each other at a pizza shop and we're like, oh, hey, what's up? How are you? Oh, yeah, doing well, yada, yada, yada. And let's go ahead and say I show her my pizza. And my pizza looks kind of like this, where it's split into 4 slices. I'm a big guy. I like eating. So, those are the size of my slices. Ariane goes ahead and says, nice. I have my box kind of like this. Hers is cut into 8 pieces. Okay, cool. So here's what happens. Ariane goes, hey, coach, I'm going to step over to the restroom for a moment and I'll be right back. Can you watch my pizza for me? I go, sure, go ahead. Staring at the pizza. She goes to the bathroom and I'm going to go ahead and just move her away. She goes to the bathroom and I have the bright idea of eating this slice right here. I ate that slice right there with no remorse. No remorse at all. Sorry, Ariane. But, to be fair, you didn't know this happened. So, with that said, before Ariane comes back, I realize, oh crap, I just ate one of her slices of pizza. Everybody, quick question. Could I take one of my slices and just replace that slice that I ate? Could I do that? No, I couldn't, right? I couldn't. I could not. Even though I ate one slice and I'm trying to put one slice in. I couldn't because the sizes of the slices are not the same. And we can all see that, right? We can all see that this is much smaller than the slices that I got. And that's the idea behind fractions. You cannot add fractions if you are not adding them of the same slice. They have to be the same slices. If they're not the same slices, you're not adding the same types of numbers. And that's the problem. Everybody, does that make sense before we get into the nuance, before we get into the actual math behind it? But the reason that you need the same denominator is simply because you need to be talking about the same relative size. That's it. That's it. So with that, let's go ahead and take a look at a little example. That example is going to be this exact scenario. Let's go ahead and say, Ariane comes back. She realizes I stole her pizza, and that's because I'm bad at math. So yeah, there we go. Story ended. But let's go ahead here and let's use these slices here and say, I have 1/4 of a pizza. So 1 out of 4 slices. And Ariane's is 1 out of 8. If we add these two together, first and foremost, everybody, do we have the same denominator here? Correct. We do not. We do not. And so with that said, what we have to do is modify these denominators, either one of them or both of them, to get the same denominator, everybody. All we want to do is get to the same denominator. Sometimes you got to modify both numbers. Sometimes you just want to modify one. In this case, you would really only need to modify one. And let me show you what that looks like. Everybody, is it true that 4 can go into 8? Is that true? Yeah, absolutely. Everybody, what do I need to multiply 4 by to get to 8? Yeah, that'll be a multiplication of 2. We all know that 4 times 2 will get us to 8. But kindly remind me, everybody, it's not just the denominator that I need to multiply to make it, 8. That's not the only thing I need to multiply. Where else am I going to be multiplying? Correct. I'll multiply the numerator as well. And remember this might sound familiar. Whatever you multiply the bottom by, you multiply the top by, and vice versa. Whatever you multiply on top, you'll multiply on the bottom. So in this case, if we're going to be multiplying the denominator by 2, we'll do the same with the numerator. And once we do that, there we are. 2 times 1, that'll give us 2. 2 times 4, that'll give us 8. So now when we take a look at this, everybody, if we were trying to add these slices together, my slice, as you can see right here, my 1/4, this right over here, my 1/4 is actually 2 of her slices. Slice number 1 and slice number 2. Does everybody see that as we transition into having the same denominator as Ariane's pizza box? We see that 1 out of 4 slices is the same as 2 out of 8. Again, this is all about how fractions work. Pizza rules the world. So with that, here we are. We have 2 over 8 plus 1 over 8. Everybody, can we actually add this now? Do we have what we need to get this done? We absolutely do. Now that we have the same denominators, we can now add the numerators. So once we do this, 2 plus 1 is going to give us 3. And everybody, what's our denominator going to be? 8 or 16? Yeah, the answer is going to be 8. The answer is going to be 8. And here's how I like to think about it. When it comes to adding and subtracting, this denominator is what you're referencing. So what I'm saying here is I have, if we're talking about the situation again, we're saying that we have 1 out of a possible 8 slices plus 2 out of a possible 8 slices. That's going to give us 3 out of a possible 8 slices. That's not going to be out of 16 slices because, no, we're referencing the 8 as the whole. That's what would make a whole box. So remember, here we go. When it comes to adding and subtracting fractions, we have to have the same denominator. If we don't, we have to get what's called the least common denominator, the smallest denominator that both of the fractions can be fit into. In this case, we just had to tuck the 1/4 as 2/8, but we didn't have to do anything with the other one because the least common denominator was 8. That was the smallest number we could choose, and the reason that we want to go with the smallest is simply because it's less math. The higher you go, the more simplifying you do later. So you can choose other denominators for sure, but it's always smarter to go with the smallest denominator to avoid unnecessary math. And so with that said, everybody, once we do have the same denominator, simply add or subtract those numerators, keeping that denominator the same, and then you're good. And sometimes, everybody, you'll have to simplify, but in this particular situation, do we have to simplify here? Is there anything to simplify? Correct again. Not in this case. 3 over 8. 3 and 8 don't share any common factors, so there's nothing to do here. The answer would just be 3 over 8. And so there we are, everybody. So let me just recap, and I'll let you take your notes in full. When you want to add or subtract fractions, just make sure the denominators are the same. If they're not, find that least common denominator. Typically that's called an LCD, least common denominator. And that way you're allowed to convert those fractions and then do the math. Keep the denominator the same, and we are good. All right, so let's take it forward here to multiplying fractions. So this is probably going to be the favorite for a lot of people, only because you don't really need to do anything before you actually multiply. You're not really required to do anything. So let me go ahead and get this going for us here. So when it comes to multiplying fractions, everybody, all we have to do, hey, take those numerators, multiply them together. Take those denominators, multiply them together. And if you need to, simplify the result. It's very, very, very straightforward. So before I let you take some time and take some notes, let's go through 2 or 3 examples here to show you how this works. So I'm going to zoom in to discourage you from writing while I talk. Again, this is only for your benefit. Now let's go ahead and go through this first example. Let's take, let's say, 2/3 and multiply it by, let's say, 5/6. So again, everybody, if we're going to go ahead and multiply these fractions, what we could do, straight up, is again, multiply the numerators and multiply the denominators. Straightforward. Everybody help me out. I'm not that good at math. What is 2 multiplied by 5? Correct, that's going to give us 10. And then what is 3 multiplied by 6? Correct, that's going to be 18. Let me use some consistent coloration here. So let me take that out of the way. All right, so now that we're here, everybody, I know someone had the question about simplifying fractions a few moments ago. And this is going to be a great opportunity to talk about how this gets done. So once we have 10/18, here's the thing. When it comes to final answers on a standardized test, like the one you're preparing for, what you're going to notice is that with standardized test answer choices, whenever it's a fraction, it's always going to be in simplest form. So this is going to be really important. So when we take a look at the numerator and denominator, we want to ask ourselves, hey, what's the biggest number that we can divide out of both the top and the bottom, the numerator and denominator? And that's going to be 2 in this case. 10 is divisible by 2. 18, yeah, that's divisible by 2. So what I'll do is I'll divide them each by 2, because remember, as long as you're doing the same thing, multiplication or division, to the numerator and denominator, the top and the bottom, you're perfectly fine. So here in this case, 10 divided by 2 is going to give us 5. 18 divided by 2, that's going to give us 9. And that right there is our final answer, and we're all good. But, my party people, who here would like to find or see ways that will allow you to save a ton of time when it comes to multiplying fractions? Okay, cool. Sounds good. Let's go ahead and try this next example here so I can really drive the point home here. So let's take a look at this next one. Let's go ahead and say we're doing, let's say, 12/7 multiplied by, and then let's go ahead and say 3 over, and let's go with, actually, no, let's go with, I want to go ahead and use something a little easier on the eyes. So let's go 5, and let's go 8. All right. So everybody, let's go ahead and try this out. Everybody help me out. Here we go. Let's do 12 multiplied by 5. That's going to give us what? Yeah, that'll give us 60. Exactly. So let me just use the same color code. So we have 5 multiplied by 12. That's going to give us 60. And then in our denominator, we're going to have 7 multiplied by 8. What's that going to give us, everybody? Correct. That'll be 56. So we have 56 right there. Now, can anybody tell me what number goes into both 60 and 56? Yeah, 2 is definitely a number there. But what's the biggest number that can go into 60 and 56? What's the biggest number that can go into each of them? Not going to be 6, a little lower, a little lower. Yeah, 4 is correct. But just take a moment to just reflect on that. Notice how for a lot of us, it really wasn't obvious, right? And I'm not blaming anybody. This is just what happens as the numbers get bigger. That's just naturally going to happen. You know, it's going to be harder and harder to really, obviously, quote unquote, for you to sensibly and obviously see what that number is going to be. And so that just, again, happens as the numbers get larger. So you don't have yourself to blame for that. You're good. But let me go ahead and simplify from here. Now that we know that we can divide them both by 4, let me show you the additional headache. The additional headache is, well, do you know what 60 divided by 4 is off the top of your head? Do you know what 56 divided by 4 is off the top of your head? It might not be obvious, right? So we have to go ahead and use a little bit of long division. Again, I'm just making the point here that this is going to take a little longer than necessary. So just follow along, humor me, I got you. So we have 4 going into 60. 4 goes into 6 one time. So 1 times 4 is 4, and we'll drop that to get a 2. Let me zoom on in right over here. So then we'll drop that 0. 4 goes into 20 how many times, everybody? Yeah, that'll be 5. So we have 15 right there. So with that, subtract the 20, no remainder, and we're good. So with that, everybody, can we confirm that 60 divided by 4 is 15? Excellent, thank you. Now let's go ahead and do the 56 divided by 4. Let's figure out what that is gonna be. So here we go, 4 going into 56. Let's see what happens here. 4 goes into 5 one time, and we'll take that 4 away, leaving a 1. Then from there, we drop the 6. Everybody, how many times does 4 go into 16? Correct, that'll be 4. So 4 goes into 16 4 times, and that's a perfect 4 times. No remainder, and that gives us 14. So the final answer here will be 15 over 14. My party people, do we agree after we did all of that math? Is that the correct final answer there? Yeah, 15 over 14, which we can definitely turn into a mixed number. We'll talk about that in a couple of slides, but yeah, that's our answer. But is anybody here excited to do all of this long division for one problem? Is anybody here really truly excited about that? Exactly, no. Yeah, I'd rather deal with Monday twice than deal with unnecessary math. So let me go ahead and show you. If we were to do the same exact problem again, let me show you how we can save time. So here we are. Let's do 12 over 7 multiplied by 5 over 8. All right, everybody, watch this. Everybody, remember what I said. Whatever you do to the top, you do to the bottom. And that's going to be true even when you have two fractions being multiplied. Instead of simplifying at the end, you can actually simplify in the beginning. Let me show you. Everybody, on the top, we have 12 and we have 5. On the bottom, we have 7 and 8. Everybody, what number can go into both 12 and 8? What's the biggest number that you can think of? Because 2 is definitely one of them, but it's on the smaller side. Correct, 4. That same 4 that we noticed we could take out at the end, we can take it out in the beginning. Watch and learn. If I divide the top by 4, the 12 specifically, and the 8 specifically by 4, watch what happens. Here we go. Let me just write the spacing for everything again. Help me out, everybody. What is 12 divided by 4? Correct. That's going to be 3. So I'll write that right there. How about this? What's 8 divided by 4? Correct. That's going to be 2. So watch and learn. We now have smaller numbers to deal with. And those original numbers, that 5 and that 7, they're still going to go where they were. Exactly where they were, no problem. But when we think about this, everyone, when we think about this, do you think that this will be an easier math problem? Instead of doing 12 times 5, we're doing 3 times 5. Instead of 7 times 8, we're doing 7 times 2. Yeah, much easier, right? Much easier. And so with that, look at what happens. Let's go ahead and multiply now. 3 times 5, that's 15. 7 times 2, that's 14. And we're done. No need for excessive long division because we took care of that simplification in the beginning instead of the end. And that's why this is going to save you time on any problem that you're multiplying fractions and you know you're going to have to simplify at some point. You might as well simplify in the beginning. So with that said, my party people, does that make sense to anybody out there? Sweet, sounds good. Right on, right on. And let me go ahead. Yeah, so Tomeo, so I see here you'd like to see more fraction problems later in the class. Of course, yeah. So today's class is going to be a lot of fraction word problems. Right now, we're just refreshing on those operations. I got you. So with that said, everybody, let's go ahead and I want you to try one on your own here, and then we'll go ahead and do it together. So here, let me go ahead and write the problem out. The problem that we will do will be right here, 10 over, let's go ahead and do 10 over 9 multiplied by, and then let's go ahead and do 27 over 15. Actually, 27, let's go ahead and do 27 over 11. Let's do that. So let's go ahead and give this a shot, everybody. Let's give this a shot. So first things first, if we decided to do this straight up, remember that we would have a pretty tough time because, sure, 10 times 27, that's 270, but then 9 times 11 is 99. If we did it straight up, it would be 270 divided by 99, which it may not be obvious how to do this, from here. We can give ourselves an easier time. Let's simplify first. Everyone, help me out. Does 27 share anything with 9 or 11? Yeah, not only does it share a 3, yeah, it shares a 9. It shares a 9 because guess what? 27 and 9 are both divisible by 9. So let's go ahead and simplify first because once we do that, look at what happens. It just gives you an easier time. We now have the same 10 and the 11, but the other numbers, 9 divided by 9 is 1, 27 divided by 9 is 3. So we just turned something that was seemingly difficult into something very quick. And now when we do the math, we're all good. 10 times 3, 1 times 11, and we're all done. So one more time, party people, does that make a little more sense? For those of us out there that were wondering, what that trick was. Again, simplifying before you multiply. Yeah, and it can apply to either number. You can actually simplify the fraction you have if it's simplifiable, or you can go cross simplification. Both will work. Yeah. So feel free here. I'm going to put another timer on the screen, take your notes, and we'll move forward to dividing fractions, and then we'll get started on our word problems. Now let's go ahead and move it forward here to dividing fractions. So this one's going to be pretty straightforward because it piggybacks off of multiplication. So when you are dividing fractions, pay very close attention here. To divide fractions, everyone, what we want to do is one thing before we follow the rules for multiplication. So let me show you exactly what I mean by working through the examples as we do it. So let's go ahead and say we are doing 1/2 divided by, let's go ahead and say 2/3. So let's say we're doing 1/2 divided by 2/3. Can everybody confirm in the chat box that yes, indeed, we do see division right here? Appreciate you. Thank you. So we have 1/2 divided by 2/3. What are we supposed to do here? Well, here we go. Let's follow these notes. So what we're supposed to do is keep, change, flip. Let me go ahead and mark these down with some highlighting. We're going to keep the first fraction the same, change from division to multiplication, and then flip the second fraction. In other words, take the reciprocal. So let me show you what that looks like. We are going to keep the first fraction the same, so 1/2. We are going to change from division to multiplication, and then we are going to flip right over here. The second fraction, instead of 2/3, we'll have 3/2. So instead of KFC, which is the famous establishment that most of us grew up on, we are going to be thinking KCF. All right, KCF, keep, change, flip. So again, keep the first fraction the same, change from division to multiplication, and then flip from 2/3 to 3/2. Follow that order, and you are good. Because from here, everybody, is it true that we know our rules for multiplying fractions? Is that true for us? Absolutely. Just got done reviewing it, right? So we're good. We can go ahead and multiply straightforward here. And so let's do that. 1 times 3 gives us 3. 2 times 2 gives us 4. And we're all done. And there we go. We can simplify at the end, or we can simplify before multiplying. But let me make myself very clear. We do not simplify here. We do not simplify here because we are not in multiplication mode yet. We are not. Once we are here or here, then we can simplify. But we cannot simplify when it's set up as division. My party people, do we understand that before we move forward? Again, you have to wait until you're in multiplication mode or you have your final answer to simplify. Do not simplify while you're in division mode. All right, my party people. Now let's go ahead here and just talk about one more quick thing, and that's it. We are starting on our word problem practice. So this one is going to be necessary, especially because we're doing test level practice. And like I said, when it comes to fractional answers, you're going to have either proper fractions or mixed numbers. Those are the two types that you'll see as answer choices, and they're always going to be simplified. But I want to talk about turning those improper fractions into mixed numbers. So for example, everybody, let's go ahead and say we have, something like this. Let's say we have 13 over 3, and we want to turn this into a mixed number because 13 over 3 is definitely bigger than 1. 3 goes into 13 more than once. So we need to figure out, our final answers when they appear as A, B, C, D, they're not going to be in this form unless they explicitly say, leave it as an improper fraction. But they're typically not going to do that. They're typically going to say, write your answer down as a mixed number. And here's how you do it. Everybody, just remind me real quick, when we're looking at a fraction, what operation does this mean? This bar right there, what is this operation telling you? What is that? Yeah, that's division. Exactly. That's all you need to know. That is all you need to know. That this means division. Let's go ahead and divide. Watch this. 13 divided by 3. Let's see how many times 3 goes into 13, everybody. How many times is that going to be? Correct. That'll be 4 times. Let me just move this down slightly and zoom on in. But what we will get is a 4 on the top, because what this will mean is 4 whole times. In terms of, hey, how many times can 3 fit into 13? It can fit 4 whole times. And that's where our whole number 4 will come into play. And then we try to think about, well, what about the fraction? What are we writing here? Well, what you're going to do, everybody, is you're going to continue with this long division. Watch. 3 goes into 13 4 times, but 3 times 4 is 12, not 13. So we're going to subtract that 12. And everybody, what do we have left over? That's a 1. And what do we call that, everybody? What do we call that number that we get at the end of long division, right there at the bottom there? Yeah, that is called the remainder, or residual for sure. But we're going to go with the remainder here for the purpose of today's class. This is your remainder. And guess what happens to the remainder? It remains up top. The remainder remains up top right there. And your denominator is the same denominator that you had before. You were comparing it in chunks of 3 or out of 3, and we'll keep comparing it out of 3. But that whole number that you get when you do the long division is the whole number. And the remainder remains up top. That's the way I like to think about it. Again, the quotient, what you get, that's the whole number, and that's how you'll write it, as the whole number. And your remainder remains up top. My party people, let me know if that quick explanation makes sense for you, if it helps you refresh on how to work on that. I'll let you go ahead and take your notes now, and we'll get started with our word problem practice right away. Let's go ahead and continue the party here. So what we're going to do is we're going to start trickling in these word problems. And so of these first word problems, this is what they're going to look like as examples. No multiple choice quite yet. And depending on how quickly and confidently we go through these warm-ups, then we'll get into those multiple choice questions that are slightly more complex and closer to test level. So with that, everybody, let's go ahead and get into this one here. So whenever we're working on any word problem, this is especially for my new folks, for any word problem at all, what is the first thing that we always want to do? The first thing we're always going to want to do, everyone, is read the question. So right over here, how much pi did they have all together? That's the question. Not Sarah had half of, no, this is the problem, but the question that you want to start off with right here, the question sentence. How much pi did they have all together? Everybody, just reading that sentence, what does this clue to you in terms of the operation that we might have to do? How much do they have all together? What does it sound like we're doing? Yeah, we're adding. This is where context matters most. So this is part 2 of today's lesson. Part 2 is, hey, can we take this English and turn it into math? So here it says again, how much pi did they have all together? So in all, in total. And so over here, let's understand the information. It says Sarah had half of a pie and Tom had a third of a pie. Okay, so basically what's going on is Sarah has this much pie, Tom has that much pie. How much pie did they have all together? Everybody, can we confirm that, yeah, for sure, we're going to be adding these two amounts together? Right on. So let's go ahead and get that done. We have 1/2 plus 1/3. And everybody, we all know that I never make mistakes. So the final answer here has to be 2/5. Is that correct? Is that correct? Yeah, not at all. Not at all. Not at all. This is only correct if I am deliberately trying to get myself fired. So with that, what we're going to do is we're going to get this out of the way, and we're going to remind ourselves that when it comes to adding and subtracting fractions, we need the same what? Yeah, we must have the same denominator. Excellently said. Yes. Again, we need the same denominator, and we do not have that. Here's the 2 and there's the 3. They are not the same. So to get that done, everyone, let's ask ourselves what the least common denominator might be. Because 2 doesn't go into 3, it looks like we're going to have to change both of these numbers. Everyone, what's the smallest, again, least common denominator? What's the smallest number that 2 and 3 can both multiply up to? Yeah, 6 works. You could do 6, you can do 12, 18, 24, 30, yada, yada, yada. But the smallest number is what we want to use because it gives us the least headache. So with that, here we go. To get to a denominator of 6 for both of these, what we'll need to do is we'll need to go ahead and multiply the 2 by 3. And make sure we do it up top as well, because whatever you do to the bottom, you do to the top. And then on the right side, everybody, what are we multiplying the 3 by to get to 6? Correct. That'll be 2. 3 times 2 gives us 6. Exactly. So here we are. We'll multiply by 2 on the bottom and on the top. And let's show ourselves what we have. 3 times 2, that's 6. So we knew that would be there. 3 times 1, that'll be 3. Then we have on the right side, again, 3 times 2, that's 6. We knew that that was the case. But here, 1 times 2, that's going to be 2. Now that we're here, everyone, 3/6 plus 2/6, what will that give us? Yeah, now that we're talking about the same number of slices in a pie, yeah, we're good. We can add these fractions because we have the same denominator. 3 plus 2, that's going to give us 5. And the final answer is 5/6. And there we are. So notice how we just started to put everything together here. The first important thing in this problem, everybody, was it the calculation? It was not. The most important thing for any word problem is to understand, hey, what is the goal of the question? Setting up your values in a way that tells a story. Everybody, are we going to be able to pay attention to the context before the calculation? Because I know how nervous a lot of us get with word problems and with fractions. So it's going to be super important to understand, hey, context first. How much pi altogether? Okay, sounds like we're going to be adding, and then we'll think about the actual numbers. And don't worry, we have plenty of opportunities to practice and go through examples, and so we'll take the time that's necessary to get this done. I got your back. So my party people, hopefully that was enough time. If you want to take a screenshot of this, feel free to take your screenshot. For those of you that are here live, this class is being recorded and I will put it up immediately after class. So you're good. But are we ready to try another problem out? All right, so remember, the first thing I want you to do, everyone, the first thing I want you to do is tell me what the question sentence asks us for. I know the fractions are going to be nerve-wracking. They're going to try to confuse you. I got you. But go straight to the question sentence. Right over here. Here's the new one. Here's the question sentence. How much of the cake is left? What does it sound like to you personally that we might need to do here? So think about that, everybody. how much of the cake is left. I'm not asking you for the correct answer. I'm asking you for what you believe the question points out to do. And for those of you that are saying subtraction, excellent. Yes, that is correct. For those of us that may not totally understand that quite yet, no worries. Here's what this means. If I'm asking you how much of something is left, it's safe to assume that you had something in the beginning, something was taken away, and now you're asking how much is left. But let me rephrase that and say that again, everybody. Is it generally true that if you're trying to find out how much of something is left, you must have taken something away? Does that make general sense to you? If we're trying to find out how much is left, well, then something must have been taken away. And that's where, again, working with word problems and working with context, that's where that comes into play. It's not going to happen instantaneously. You can't expect to become a master in just 2 questions. That's not how this works. It takes time and repeated exposure to get to where we need to be. So with that said, everyone, if we're trying to find out how much is left, we have clued into ourselves that, yeah, we're going to be subtracting. We're going to be subtracting at some point. Now our goal here is to understand the information. Again, I know it's going to be pretty easy to be confused by fractions, but let's read around the numbers. So watch this. Jenna baked this much of a cake, but sold this much of it. So she made some and she sold some. Everyone, is it fair to say that if we want to know how much cake is left, we take how much she made and then subtract what she sold? Does that make sense to you personally? If I want to know how much is left, we're going to subtract what we sold to see how much is left. Awesome. Now, look, we have fractions. We have rules for fractions, but does everybody understand that this is what needs to be done? 3/4 minus 1/3. Even if you're not confident in how to get this done, this is what needs to be done. Subtracting 1/3 from the 3/4. Exactly. The 1/3 isn't there anymore because we sold it, so we have to take it away. Exactly. So, everyone, now that we're here, now that we're at the part where we are calculating, can anybody tell me if we are ready to subtract right away? Correct. We are not ready to subtract right away. We are not. No. Because we do not have the same. Exactly. We don't have the same denominator. Exactly. We need the same denominator. Right now, these 2 pizza boxes have different size slices. We need to have the same size of slices. If we have the same size, we can then subtract. So let's go ahead and get it done. Everyone, look at those denominators. We have 4 and we have 3. With these denominators, what is the common denominator? What is the smallest number that they can both multiply up to? Correct. They can both multiply up to 12. 12 is a least common denominator between these 2 numbers. And again, this takes knowledge of your multiplication tables. 4 and 3 can both go up to 12. So with that, what am I going to multiply this fraction by to get that denominator of 12? Correct, that'll be 3. So we have times 3 over here and times 3 over there. 3 times 3 is going to give us 9. And then the 3 times 4, that's where that 12 comes into play. Now, part 2. What do I need to multiply this by to get to 12? Correct, that'll be 4. 3 times 4 is indeed 12. And so with that, we'll do the same up top. 1 times 4, everyone, is going to give us what? Correct, that'll be 4. So now that we're here, remember what we needed to do, what we needed to focus on first was getting the same denominator because we can't subtract unless we have the same denominator. Now that we got it, now that we're here, okay, now we're good to go. We can subtract nice and easy, keeping the denominator the same, keeping that 12 right there. And now all we have to do is 9 minus 4. 9 minus 4 is indeed what? Yeah, that's going to be 5. So we have 5 over 12. That's how much of the cake is left. 5/12 of a cake. So is anybody here that was previously confused about the same denominator concept? Is anybody here feeling a little more confident, slightly better about working through a word problem? Because remember, I'm not looking for us to feel perfect instantaneously. I'm simply looking for you individually, I'm looking for you to understand what you're struggling with, and then we can take the next step from there. That's really it. I'm not asking you to get this down to perfection, just asking you to be better than you were before. So with that, let's go ahead and try another problem out. So let's try this next one here, everyone. Let's say we have this right here. Everyone, read the question sentence immediately. What does it say? How much paint does he have left? So if you're confused with fractions or not, let's put that in the back of our minds real quick. Think about this in English. Think about this like a normal situation. We want to know how much paint does Michael, how much paint does Michael have left? Everybody, again, when we talk about the key phrase, how much is left, is subtraction not the first thing that comes to mind when we think about how much of something is left? Because again, we've taken something away. That's what that implies. If you're trying to find out how much of something is left, you have taken something away. And so once we're there, again, how much does he have left? Again, indicating subtraction. What we now have is this, the situation. Let's read it. Michael has this many liters of paint, and he used this many liters for his project. Everybody look, if we didn't even have these fractions, let me show you how easy this problem would seem. If I just wrote over this, it's right over that, nice and easy. And let's say Michael had 10 liters of paint and he used 4 liters for his project. For those of us that are confused about fractions, answer the question for me. Only those of us that were confused. If I had 10 liters of paint and I used 4 liters, how many liters do I have left? Yeah, 6. 6. That's the point I'm trying to make, everybody. The point I'm trying to make is that fractions are just numbers. They are just numbers. They have their own little rule set to work with them, but they are still, at the end of the day, just numbers. It does get in the way of your ability to interpret what's going on when the numbers look confusing. I totally agree with you. It can be frustrating when confusing numbers are in there. But the ability, the skill that you really want to nurture is the ability to read around the words to understand what they mean. That's the biggest thing that I can offer you today, everybody. So Michael had this many liters of paint. He used this many liters for the project. How much is left? That is straight up subtraction. 7/8 minus 1/2 is what we're trying to do. But what we have to figure out is the least common denominator. Because again, if we are subtracting fractions, we have got to make sure those denominators are the same. What is that denominator going to be, my friends? We can definitely go to 16. But what do you notice about 2 and 8, everyone? Can 2 go into 8? Yeah, it absolutely can. And so with that said, we actually don't need to modify the 8. Again, we can go to 16, and I'll go ahead and show you both ways. I'll show you what that looks like too. But with this problem, you can just modify the 2 to go up to 8 and leave it as is. So let me actually work on it like that, and I'll work on it the other way so everybody sees both times or both ways. So here we go. I'll go ahead and modify the 1/2 here, multiply the bottom and the top by 4. Because once I do that, guess what? We have the 8 that we're looking for. So we have 7/8 minus 4/8, because again, 1 times 4 is 4. 2 times 4, that's going to give us 8 right here. And now that we're here, everyone, what is 7 minus 4 going to be? Yeah, that's just going to be 3. And then 8 minus 8, we don't do that. We leave the denominator the same. 3/8, and we are done. Boom. So who here wants me to show you the other way where we would have chosen 16 as that least common denominator? I got you. No problem. No worries at all. I want you to be curious, so I'm glad you are. So with that, let me go ahead and show you here. Same problem. 7/8 minus 1/2. I don't want you to feel like you made a mistake if you went with 16. I'm just going to show you how you're going to have to take an extra step at the end. Let me show you this. Everybody, let's assume we're going to 16. What do I multiply 8 by to get 16? Yeah, if we're going that route, let's go with the times 2. Times 2 up top and the bottom. So what we'll have is the 16. 7 times 2 is 14. Next up, let's go ahead and modify the fraction on the right side. Everybody help me out again. What do we multiply 2 by to get 16? Correct. That's going to be 8. So if I multiply 2 by 8, that's going to give me the 16 I'm looking for. And then 1 multiplied by 8, everybody, that's going to be 8. When we subtract, everyone, what is 14 minus 8 going to be? Yep, that's going to be 6 over 16. Now, what did I say earlier, everybody? When it comes to the standardized test that we're preparing for, 6 over 16 may not be the simplest form. We have to write our final answers in simplest form. Yeah, we have to. What number goes into both 6 and 16? What number can we get out of both? 2, correct. 2 can be divided into both 6 and 16. Not 3. 3 cannot go into 16. Not 6, because 6 can't go into 16 either. So with that, it's going to be 2. Let's go ahead and get it done here. 6 divided by 2 and 16 divided by 2. 6 divided by 2 is 3, and 16 divided by 2 is 8. And there we go. Same exact answer, but notice that we took an unnecessary step at the end. That's really all I wanted to show you. Both ways can still get you the same correct answer, but one will take significantly less steps versus another. That's what I want to show you there. Who here is starting to understand that when it comes to getting those common denominators? Good. Very good. Yeah, we'll definitely continue doing more problems. I got you. Class is not over. I know you're excited. I got you. So let's go ahead and give another one a shot. Let's go ahead and change up the operation here. Let's go ahead and take a look at this one. Let's take a look at this one. So everybody, let's read the question sentence first. The question sentence says, how much oil does she need? Right there. Let's only highlight that, everyone. Let's only highlight that. Everybody, does this tell us how to do what we need to do? Or does it just tell us what we need? What does this tell us here? How much oil does she need? Yeah, so far, everybody, all we're told here, all we can really get from this is that we just want to know how much oil she needs. That's it. That's all I can see. That's all I can tell from that. You know, we don't want to make assumptions. We don't want to assume that it's one operation or the other. We have to let the problem tell us what it is that we're trying to do. And so far, with just the question sentence, how much oil does she need? Well, we know that we're looking for the amount of oil needed. That's all I can say. I don't know what operation that means, but I know that we're looking for the amount of oil needed. Now, I'm looking at the chat box. And so before I break everybody's heart, does it make sense that, again, the red highlight doesn't say anything other than we just need to figure out how much oil we need? Can we understand that before I continue? All right, sounds good. Now, everybody in the chat box mostly assumed that we're trying to add here. That's not the case. That's not the case, but remember, I want to show you why. Here we go. Let's read the actual context. Remember, these fractions are going to seem confusing. These fractions are going to confuse you. Don't read the fractions, read around them. It's not about what the numbers are, it's about what they mean. Here we go. Tina's cooking recipe requires this much or this many cups of oil. If she is making 3/4 of the recipe, again, the recipe being 2/3 of a cup of oil, everybody help me out. Let me go ahead and highlight this here. This is going to be pretty interesting, especially if you don't have that much experience working with this. She's making 3/4 of the recipe. Let's write that down. 3/4 of the recipe. Okay, so everyone, we have a phrase here, a very specific math phrase here, the word of. Write this down if you need to, because it looks like a couple of us do. I got you. Everybody, we have two key phrases. We have the word of and then the word out of. Everybody, when we think of the phrase out of, this one specifically, what operation is that? If I say, 5 out of 10, or if I say 20 out of 30, yeah, that's division. When you're saying this many out of that, you're trying to see how many of those fit into the other. Out of is division. However, everyone, However, does this say out of? Does that say out of? No, it does not. It says of. My friends, what does the word of by itself mean? Yeah, of is multiply. Out of is division. One more time. The word of by itself, that is multiplication. The phrase out of that is division. That's right. So Hieshia, yes, you are right. It is multiplication. What we're doing here, yes, that is correct. And so let me help us out here. Let me get this out of the way and let's remind ourselves. So we have 3/4 of the recipe, 3/4 of the recipe. Here we go. We'll write the 3/4. Everybody remind me again in the chat box, the word of is what operation? That's going to be multiplication, correct? And how many cups of oil is the recipe? How many cups of oil is the recipe? Yeah, it's 2/3 of a cup right here. Read this, everybody. Let me just circle this here. The recipe requires 2/3 of a cup of oil. So the recipe that we're going to bring down, that recipe is 2/3 of a cup of oil. Notice how this was not easy. This was not easy in terms of setting it up. But when we break down the individual pieces, where it says we're making 3/4 of the recipe, we can take this with our experience and understand that the word of means multiplication. The recipe calls for 2/3 of a cup of oil, so we'll replace the recipe with 2/3. And then from here, then we can go and move forward with the actual calculation. Before we calculate, who here is feeling even slightly better about your ability to notice the English and turn it into math? Even if it's just refreshing and writing down that the word of is multiplication and out of is division. Who here is feeling like there's a refresher starting to happen? Perfect. Yep, exactly. Annotate that thing. Exactly. Yes. Write that down. Perfect. Sweet. So we have completed the part where we translate the English into math. Now let's go ahead and actually do the math. So remember, it's 2 phases to every word problem. Translating first, calculating second. Now let's move forward and calculate. Everybody, does anybody notice anything cool about this problem? Anything cool, anything, convenient about this one that we can do? Yeah, we have the 2 and the 4. But what else do we have? What's the more obvious simplification that we can do here? Yeah, the 3s. The 3 on the top and the 3 on the bottom. To better help you appreciate this, let me just go ahead and multiply straight up to show you what happens. 3 times 2, that's going to be 6. 4 times 3, that's going to be 12. Once we're here, we can simplify because 6 and 12 are both divisible by 6. And so once I do that, 6 divided by 6 is 1. 12 divided by 6 is 2. And this becomes 1/2. And if you look at this, everybody, isn't 6 half of 12? Isn't 6 exactly half of 12? It absolutely is. And that's why it turns into 1/2, because that's the relationship. Remember, a simplified fraction doesn't change the value. It's just the simplest way to express the relationship. 6 is half of 12. We can just say 1/2. And it makes life so much easier. We can also go the other way. We can simplify dividing the 3 up top and the 3 on the bottom if we wanted to. And that would have given us 1/4 times 2/1. If we would have done it that way, we would have had 2/4, still allowing us to simplify to get that 1/2. Either way, we still would have been fine. 1/2, either way. Does that make sense, everybody? Are we good on this one? I think the biggest point for this problem is really going to be knowing that the word of is multiplication, the word out of is division. That's really the biggest takeaway from this one for sure. Who here would like to see a division example before we move forward? Right on. Let's go ahead and give it a shot. So here's the next one. All right, everybody, here we go. Let's go ahead and give this one a shot. Let's read the question first. So how many pieces can she make? So how many pieces can she make? All right, everybody. Does that question Because remember, the question sentence is always going to tell you what you're looking for. Here it says, how many pieces can she make? So, some way, shape, or form, I'm looking for how many of these pieces that Jess over here can make. However, everybody, does the question sentence specifically, pay attention, the red highlight here, does that reveal what math we need to do yet? Correct. It doesn't reveal it quite yet. This red highlight by itself does not reveal what I need to do yet. It reveals what I want to find. Yes, absolutely. But it doesn't tell me the math that I need to do. So here's where we need to pivot and move into the actual context, the reading here, the wording. Let's read. It says, Jess has a 3/4 yard long ribbon and wants to cut it into pieces that are each 1/8 of a yard long. Okay, is anybody here confused by the fractions in here? Yeah, right? The fractions themselves can be a little tricky sometimes. Now, let me help you out, everyone. Let me help you out. Let's go ahead and change the numbers so I can show you how easy this problem can be if you're paying attention to the words and not the numbers. Watch this. Everybody, let's go ahead and say we have not that ugly fraction. No. Let's say we have an 8-yard long piece of ribbon, and what we are trying to do is cut it into pieces that are each 2 yards long. Let's change it to that, everybody. Let's change it to this. So if I had 8 yards of ribbon and I wanted to make pieces that are 2 yards each, what operation does it sound like I need to do? It sounds like I'm trying to see how many groups of 2 yards I can fit into 8. What operation is that, everybody? Yeah, that's division. Absolutely. So for those of us that are confused about, again, noting those operations, those key words, are you able to read this and understand that this is division if I change the numbers to easier numbers? So if this person, Jess, had 8 yards of ribbon and wanted to cut it into pieces that are 2 yards each, oh yeah, that's division all the way. It doesn't matter if we take the numbers and turn them into fractions. It is still the same operation. We have this much ribbon. We want to cut it into pieces that are each this long. That is division. For those of us wondering why we're not using multiplication, remember the word each, it gives multiplication or division. It always depends on what you're looking for. If you're looking for the grand total, yes, it will be multiplication. If you're looking for one of those things, like the smaller pieces, that is division. Everybody, are we being asked to find how much ribbon we have in total? Or are we asking to find how many pieces or how much one piece is? Which one is it? Are we looking for the grand total or the pieces? Exactly. So let me write this down for us. Feel free to write this down as well. When we're dealing with the word each, we can think about multiplication or division. I got you guys. I can see that this is important to y'all, so let me help you out. So we have multiplication and division. Here's how you know when to use each. So for multiplication, when you want the grand total, that's when you know you should multiply. So if we were to say something to the effect of, hey, we have pieces that are each, 1/8 of a yard long, and we want to make 50 pieces. How much ribbon do we need in total? That's when you would use multiplication, because you want that grand total. Division, when you're trying to find pieces, when you want to find individual pieces, that's when you use division. For anybody out there, does that help you out? Does that make a little more sense than it did before? With the word each, when you want the grand total, you multiply the pieces you have. When you want to find the individual pieces, you divide to get down there. Excellent. Now let's go ahead and show what we have here. So like we said earlier, we're going to take the 3/4 yard ribbon and we're going to divide it by 1/8 of a yard long per piece. So here we are. We'll have 3/4 of a yard of ribbon, and we will divide that by 1/8 of a yard of ribbon. Pretty much all we're saying is, how many times can we fit 1/8 of a yard into 3/4 of a yard? And now that we're here, everybody, what are the 3 letters we got to think about? Jaslyn, appreciate you. Yep, keep change, flip. Keep, change, flip. We are going to keep the first fraction. So we will keep the first fraction the same. We will change the operation from division to multiplication. And we will flip the second fraction here. Let's use purple. We will flip the fraction from 1/8 to 8/1. And there we are. So now that we're here, everyone, are we ready to perform the operation? Are we good to go? Oh yeah, we can definitely simplify beforehand. We absolutely can. But yeah, we're ready to go. We're ready to go. Remember that because this is not addition or subtraction, we do not need to have the same denominator. We don't. We are multiplying now, so all we got to do, simplify or multiply, whichever one, and then simplify at the end if you need to. So with that, let's get into it. Everybody, if we're doing 3/4 times 8/1, what this can turn into is 3 times 8, which is 24, 4 times 1, which is 4, and everybody help me out. What is 24 divided by 4? What's that going to give us? Yes, that is going to be 6, and there we go. We can make 6 pieces of ribbon with this 1/8 yard long per piece, and having this much ribbon in total, we can make 6 pieces all together. And there we go. There we are, everybody. How are we feeling about this problem? Good, better, confident? Yes. Love hearing it. Love hearing it. Now, we still have plenty of time today to keep practicing. So let's go ahead and keep practicing. So with that, let's go ahead here and move into one more division problem. So let's go ahead and try this next one out here. Right there. Let's keep it going, everybody. So what are we looking for in this question? I'm not asking you what operation. What is it that we are looking for here? Right, we're looking for the number of doses. That's what we want. How many doses can he obtain? Right there. How many doses can he obtain? Okay, sounds good. How many doses can we obtain? Everybody, does that tell us the exact math we need to do, or do we need to keep reading for that? Does that red highlight tell us exactly what we need, or should we keep reading? Yeah, we need to read more. Because when we ask ourselves, like, how many doses can he obtain? Well, we don't know the context yet. We don't know if we're adding things up, subtracting, multiplying, dividing. No, we don't know yet. We don't know yet. So let's go ahead and read the situation. Now, Sam has this much of a liter of medicine. If one dose uses this much of a liter, how many doses can he obtain? So think about it, everybody. Think about it. If we have this much total medicine and one dose requires this much of a liter, everybody, there's a secret word that's here that's not actually shown. What's another way to say one dose? What's another way to say if blank dose uses 1/3 of a liter? Yeah, Ariane, you got it. Yeah. Everybody look. The word one dose, that's the same as saying each dose. If each dose uses 1/3 of a liter, how many doses can he obtain? Again, one and each, they're interchangeable. They absolutely are. So here we have Sam has this much of a liter of medicine. Each dose uses this much of a liter. How many doses can we obtain? Does everybody here notice that we have the grand total right here, the word each that we can extrapolate from this. So we have the grand total. You see the word each. We're trying to get how many doses, how many pieces. Which one are we doing, everybody? Multiplication or division? We're not trying to get to the grand total. We're trying to get to the number of pieces. So yes, that will be division. Let me grab this from the previous problem. I got y'all. Let me copy that and paste it right here. So again, if we want to find the individual pieces, so how many individual doses we can obtain, it will be division. So we'll start off with our grand total, 5/6, and then we will divide each dose. Each dose is 1/3 of a liter. If we do it this way, we will get to the number of doses that we can obtain. Everybody, are we ready to straight up do something, or do we have to, Is there something we have to do before we actually perform this operation? Yeah. KCF, keep, change, flip, just like we did previously. So here we are going to keep that first fraction the same, 5/6. We are going to change the operation from division to multiplication. And we are going to flip that second fraction from 1/3 to 3/1. Now that we're here, are we ready to multiply? Yeah, absolutely can. And also, if we wanted to, we could simplify beforehand, which I would recommend doing that. Let's go ahead and simplify beforehand, noticing that we have a 3 up top and a 6 in the denominator. We can absolutely simplify first, for sure. And so, to simplify here, we will divide 3 out of both the numerator and the denominator, top and bottom, nice and easy. And so once we do that, we will go ahead and have 5 up top still, the 1 on the bottom over here. But from the top right, 3 divided by 3, that's going to give us 1. And then 6 divided by 3 for the bottom right here. 6 divided by 3, that's going to give us 2. Now that we're here, 5 multiplied by 1. Now we can just multiply nice and easy. 5 times 1 is 5. 2 times 1 is 2. And there's our answer. However, everybody, the answer is probably going to have us write this as a mixed number. What do I do to turn an improper fraction into a mixed number? How do I do that? Yeah, we want to divide, exactly. We want to divide, and once we divide, the remainder is what remains in the numerator. Remember, the remainder remains in the numerator. So let's go ahead and take care of business. We're going to have here 2 going into 5. So 2 goes into 5 twice because 2 times 2 is 4. But it's a 2 as a whole number that comes out. That's the whole number of numbers. And 2 times 2 is 4, so we'll subtract. And we have 1 left. Everybody, what is that number 1 referred to as? Yeah, that's the remainder. That's what remains up top. That's what remains in the numerator. So we have a whole 2, and then we have the remaining 1 up top. And we keep that same denominator, the 2 that was originally there, which makes 2.5. So 5/2 is the same as 2.5. These are the same. So if the final answers were all mixed numbers, this is what you would have to do. If your final answers were all mixed numbers, that is what you would have to do right there. Right. But if this was a standardized practice test problem and you saw multiple choice options, I guarantee you that more often than not, that final answer will be a mixed number. So yeah, mixed number is where you have a whole number and a fraction on the side. So 2.5. That's how that reads. That is a mixed number where you have a whole number and a fraction. You mix the whole number and the fraction together. Yeah, and Nicole, so 2 3/6, that's right there. You're super close. But you are correct. Because you didn't simplify, you didn't get the same answer, but technically you have the same value. Yes, you do. You just wouldn't see it written on the answer choices until you simplified it. Awesome. So with that said, up to this point in class, my party people, where is your confidence first? And I'll ask a second question after this, but what are you feeling confident on at this point? Do you feel like you've got adding fractions down, subtracting, multiplying, dividing, the keywords and word problems? Where are you feeling confident at this current moment in time? Okay, so still getting better. Definitely need to understand the concept. Feeling good, but give me something specific here. What are we feeling good on? Tailor the key phrases, feeling good about that. Feeling confident with addition and subtraction. Got to practice. Multiplication is something you're feeling good on. Okay, right on. Okay, now let's go ahead and talk about what we feel like we need to continue working on. What do you feel like you personally really want more work on? Do you feel like it's going to be translating those keywords into the actual setup? Do you feel like it's division or multiplication? Yeah, the keywords. Yeah, I feel you on that. No problem. Identifying multiplication or division, so working between the two. Absolutely, I agree with you there. That's important. Okay, so a lot of us feel like translating those keywords is a huge issue that we really want to address. Yeah, no problem at all. I got you. I got your back. So with that, let me go ahead and pull that up here. Let's go ahead here and look at our first multiple choice question. Let's check that out. But before we do, I want to give everybody an opportunity here to take screenshots of the main notes that we had earlier. So I'm not giving you the chance to write everything down again. I just want you to take screenshots of this in case you need it. So just remember, when it comes to adding or subtracting, we got to get that least common denominator first before we add or subtract. So I'll keep this up here for 5 more seconds, but that's just a quick reminder. Adding or subtracting, we need that denominator to be the same first. Then we can add or subtract. Now let me move forward here to number 2. Number 2 going forward in 3, 2, and 1. So when it comes to multiplying fractions, remember everybody the rule for multiplying fractions. Just multiply the numerators and denominators, and that's it. So numerator times numerator, denominator times denominator, and then simplify if you can. Just like that. Next, with division in 3, 2, and 1. With division, basically division. You are one step away from turning it into multiplication. You just have to keep, change, flip first, and then you just follow the rules for multiplication once you have it in that form. Everybody, with those operations, do you have those written down at the very least so you can continue practicing that even after class ends? Right on. So here's what I want to do. I want to give you all your first timed question of the day. Hopefully we can get 2 timed questions here in today. So let's go ahead and give this a shot. So let me go ahead and put this problem up. So here we go. Boom. So here's our practice problem, our first one of the day. I'm going to give you a chance to try this out right now, and then we'll come right back and we'll work on it together. So let's give this one a shot here. So, my friends, what's the first thing we've always said? What have we said? The first thing we want to do, correct, is read the question. So here it is. How many loaves of bread can be baked? Remember, what we always want to look for are those question action words. The who, what, when, where, how many, which of the following. Those are always what we want to look at. So here it says, how many loaves of bread can be baked? Now, this tells us that we're looking for the number of loaves that we can bake, but we don't know what math we have to do yet. It's not obvious, but we do know that we want to know the number of loaves that can be baked. Everybody, let's move forward here. We want to know the number of loaves that can be baked, and here it says that the baker has 48 cups of flour. Okay, let me highlight that. The baker has 48 cups of flour. Now, what do we do with that? Well, it says, hey, look, if 1 loaf of bread requires 3/4 of a cup of flour, how many loaves can be baked? Everybody, think about this. This is very similar to some of these questions that we've seen before today. Exactly. Jaslyn, the word one, it can be interchanged with the word each. Think about it, everybody. If I say, if 1 loaf of bread, ... Isn't it true that I can change if 1 loaf of bread to if each loaf of bread? Isn't it true that I can interchange that? Yeah, we absolutely can. Let me go ahead and underline those. 1 and each, they are the same. They're telling you essentially how much you need for each loaf. And if each loaf requires 3/4 of a cup and our grand total is 48 cups of flour, we're trying to see how many loaves, how many pieces we can make from that. Everybody, what operation are we doing? Is it multiplication or division? Correct. It's going to be division for that reason. Exactly, Baj. We already have the grand total. We already have it. So with that said, it's going to be division. We have our grand total, 48 cups, and we're going to divide it by the number of cups that we need per loaf, which is 3/4 of a cup per loaf. Now, my party people, is anybody here confused about having 48 a whole number instead of a fraction with division? Is anybody here looking at that like, okay, I figured out it was division, but now I'm a little stuck? No worries, I got you. I got you. Here's how we do it. Everybody, isn't it true that if I were to write really any number, if I were to write, let's say 3, that 3 is the same as 3/1. Is that true? Because 3 divided by 1, if we do the math there, yeah, that's still going to be 3. So yeah, that is true. So how about, let's go ahead and say 10. Everybody, is 10 the same as 10 divided by 1? Yeah, absolutely true as well. Absolutely. Okay. So then what does that mean? That means that, hey, 48 is the same as 48 divided by 1. And there we go. So we can write that as 48 over 1 instead of just 48. And now we have ourselves a cleaner proposition here. We can get this done a lot more smoothly. So are we good to proceed with the calculation here, everybody? Yeah, not quite, because all we got to do before we continue is keep, change, flip. Y'all are on the money. There we go. Now that confidence is starting to show. There we go. When you're eager to tell me that I'm wrong, I love it. So with that, let's go ahead and do keep, change, flip. So with that, we keep the first fraction the same, 48 over 1. You change from division to multiplication. And then you flip from 3/4 to 4/3, 4 over 3. Now that we're here, everybody, let's get it done. So we can try to simplify beforehand, but if you're not quite sure on what needs to be done to simplify beforehand, you're good, everybody. You're absolutely good. We can just multiply straight up and then divide by the 3 at the end. We're good. We're fine. So here we go. 48 times 4, and then 1 times 3. So 48 multiplied by 4, let's figure out what that is. 48 times 4, 8 times 4, that's going to be 32. Carry the 3. And then 4 times 4 is 16. 16, carry the 3. That'll be 192. So right there, we have 192. And then in the denominator, we're going to have 3. And so from here, what we'll do is we'll divide 192 by 3. So let's finish up the operation here. So again, it's okay if you didn't simplify in the beginning. Just know that it's going to take a step or two at the end. Totally fine, right? So here, 3 going into 1, it doesn't. 3 going into 19, it does. 3 goes into 19 6 times. 3 times 6 is 18, so we're just 1 away, 1 shy. And so with that, we'll drop the 2. So we have 12 now. Everyone, 3 goes into 12. How many times? Correct, that'll be 4. So 3 times 4, that's going to give us 12. There we are, and we have 64. And there we go. There is our final answer. 64 loaves of bread can be baked. And there we are. There's our final answer. If you would have multiplied accidentally, you would have gotten A, 36. If you would have multiplied accidentally before realizing that it's actually division. So with that said, who here feels like even if it took all the way until the end, we're feeling a little better than we did before?